Okay, so in the beginning of class, we saw unit tests. What we were testing is the unit of the program, your class. And so we were looking specifically at the student class, and we were calling its constructor. We were implementing its toString method. We were, refactoring things, adding private methods, et cetera, et cetera. And unit tests are cool, and unit tests form a great foundation. But there's another kind of testing, automated testing, that I wanted to talk about now, which is called integration testing. So, um, loosely defined, integration testing is all about testing how different components of your program work together, how they integrate together. And really, anything that's larger than a single class could qualify as an integration test. More usually, however, an integration test has a couple of characteristics. One, oftentimes there's like some external dependency, meaning that an integration test, for instance, integration test for a web application may require that a web server is running, or that a database is running. That sort of more components are up and running, and as a result, integration tests require more effort to set up and often run for longer. But what they do is they exercise not your functionality in isolation, but your functionality moving across different parts of your system. For this class, well, for right now, for the first couple of projects, we're going to see some integration tests that interesting. Integration tests that execute the main method, and it's broken right now. I need to get fixed. So why is that? That is interesting. Oh, maybe I need to. So I did some refactoring recently, and oops. And I've got an old version of the library right here. Main method results instead of get out. Oh no, it has this. So why doesn't it like that? Get text written to standard. Get text. No, okay. Interesting.
Does the red line tell you anything?
It just says it can't find it. So why is that? So whatever this thing is using to compile against it. So I'm going to go look real quickly at my libraries. And I'm going to say, now for you guys it's working, right? If you look at that, sorry. If you look, if someone could, look at the student IT, or probably for you guys, the the Project 1 IT, what's it called for you guys? Yeah, Project 1 IT. Like it's red for me here, because it's getting the wrong version of the library. But do you guys see that also in your Project 1 IT? IT stands for integration test, by the way.
My results get text written.
It's able to see it? Okay, well that's good. That's good if it's working for you guys. I don't know why it's not working for me. I probably just need to do something like the following. I need to go over to my project. Let's see, project parent projects. Get branch, I'm on master, right? Yeah, I'm on master. So if I say Maven install, Maven clean install. So probably what's going on is that my local Maven repository has an older version of the artifact. So from the Maven screencast, the way Maven works is that yes, there are these remote repositories, all the artifacts out there on the internet someplace, but they all get downloaded to your local repository here in M2 repository. And so then, let's see here. Now I just got to tell IntelliJ that it needs to go reload that. So if I say synchronize, will that work? Synchronize. No? Aha, it did. Okay, good deal. So what I just did is I rebuilt the library, deployed it locally by using Maven install, and now things seem to be working better. Great. Maybe I should edit that out of the screencast. I don't know. Okay. Where were we? Ah, yes, integration tests. So if you think about your projects, you're going to have a couple of classes. You're going to have your flight class. You're going to have your airline class. You can have unit tests for both of those guys. And what unit tests do is things like create objects and invoke methods. Uh, and you can but then there's also your main method. Now your main method drives the whole thing, and your main method does things that are probably a little different from your other methods. Like it'll write to standard output, it'll write to standard error, it will call system.exit, right? So system.exit exits the JVM. You don't want to exit the JVM during a unit test because then the rest of your unit tests won't run, right? So because it has that functionality, so it's doing things like interacting with standard output and standard error, and it's doing things like exiting the VM, calling the main method is more like an integration test than it is the unit test because it's got these external dependencies on standard out, on the VM exiting and things like that. So, however, you should still test the functionality in your main method. It's really important to do so. Now, you could factor your code in such a certain way so that most of your behavior is in methods that can be unit tested, and that's a good thing. But at the end of the day, you should have some end-to-end tests here in your integration tests. So I wrote a class called Invoke Main Test Case, which lets you do things like invoke a main method inside JUnit and do things like write to standard out and call system.exit, and you can verify all of that stuff inside your automated test, inside your integration test. So what I'd like to do now is the following. I want to walk you through how to use all of this stuff. But first, I want you to do some brainstorming. So we went through, and when we wrote the unit tests for our student class, that was mostly me with a little bit of input from you guys. I'd like to turn it around now. I'd like you guys to spend, let's take a total of 10 minutes, look at the command line arguments here, and on Google+, so please divide it up into like groups of 4, maybe 5, and brainstorm some test scenarios for the main method. So think about what inputs that you can give and what outputs you should expect. And then here again, and follow that given, when, then. So say, hey, when the command line is given this stuff, and I execute the command line, then I expect these things to happen. And please come up with, let's say, 5. In 10 minutes, let's do 4. Given, when, then scenarios, and post them to the community. I'll start a thread right now. So let's do that for 10 minutes. I will pause the recording. Okay, awesome. Can you guys post your stuff to the Google community? Let's see what we got. Okay, we got a couple so far. Thank you very much. Let's hear from Josh and company. Okay, a couple good scenarios here. Too few arguments, too many arguments. GPA is not numeric. Good thing to test. Classes are not in correct format. I wonder what that means. Okay, from Amanda and friends. Excellent. So we actually have some real command lines here. Unfortunately, because you have a dash jar, it dashes everything out. It's not too smart there. But this is really cool. So this is like a very precise scenario, right? So it's like, hey, when you specify these things, you have an exit code of 0. Nice. And here's a scenario where, okay, you've got, all right, you have a GPA with a value of B, and so we should, this is like, there should be like an error message, like invalid GPA. Nice. Excuse me. Exit code of 1. Okay, yeah, so this is good, and actually it'll be really easy to turn this stuff into test cases here. Shraddha, no input at all. Oh, that's cool. Partial input, so some stuff missing. GPA, good. GPA is greater than 2 decimals. Oh, that's cool. From Liz and friends. Yep, here again, some missing from the command line. Oops. Oh, good. And given, when, then. So let's see here. So given that there are no command lines, then, yeah. So this is, how I like to think about things. Like, hey, given you've got this stuff from the command line, when you execute that command line, then stuff happens. Nice. Okay. Oh, great. Invalid type argument. Program should print out appropriate message. Yeah. Okay, from Jason. Less than 3 arguments. Yep, given, yeah. Okay, yep. Invalid double. Oh, this is interesting. Okay, properly formatted input. Nice. Okay, I'll reload to see if there are any other ones. Oh, yep. Great. Some more from Andy. Oh, okay. Even put in the name of a test. Very nice. Single course name. Wouldn't have quotations. Single name course. Yeah. Right. Sort of like the example. Yeah. Making sure that we can do the example there in the project. Ah, good. Some happy path and some unhappy path. See here some stuff that we've seen before. Oh yeah, GPA is more than 4.0. Great. Yep. Okay, stuff excellent. Okay, like more of the same. I want to start writing some code. Cool. So let's come back to this. Okay, so you guys can all see it there and play along at home. Okay, so let me talk a little bit about what we've got here in this integration test. So Project 1 IT extends a class that I wrote called Invoke Main Test case. And what this does is it provides some methods like invoke main, and there's some magic going on here. So I'm not going to go into the details, but basically what you do is you say, hey, I want to invoke the main method of some class, and the way that you specify the class is you give the name of the class, say .class, and as someone was talking to me at break, it's like, hey, what does the syntax mean? And I'm like, there's this lecture in week 4 all about reflection, and it'll blow your mind, man. And so then feel free to skip ahead now, but it'll blow your mind, man, because it talks about all this metaprogramming that you can do in Java with like this class and everything. And so invoke the main method and provide some command line arguments. And notice this takes a variable number of arguments, so the 3 dots means var args. So just like, like sprintf and C and stuff like that, you can give it a variable number of arguments. You can do the same thing here, so it makes it easy to express stuff like the following. So when you say here in our test, you can say no command line arguments. You're saying, hey, this will invoke the main method, which calls this guy up here, and invokes the project 1 main method with no arguments. This returns something called a main method result. This goes off and runs the main method, and it has some magic that'll do things like capture standard output and standard error, and also if there's an exit code, it'll return the exit code. And we'll say, great, all that's wrapped up in this object here, and then we'll assert that the exit code was 1, because this is an error when it has no command line arguments. And then the text that was written to standard error contains a string missing command line arguments. And so then all of this, I'm sorry, this is project 1. I meant to be doing this for a student, which is hopefully the same thing. Pretty much. Here we invoke main, we give it the name of the student class. Here again, no arguments. Here we have a separate, I guess we put those in 2 separate test cases. One, we invoke it with no arguments. We invoke the main method with no arguments. You get exit code of 1, and also it prints missing command line arguments to standard error. And sure enough, if you look at the main method of student, that's exactly what it does. Prints missing command line arguments, standard error, and then exits the VM. When you run this test case, it doesn't really exit the VM because here again there's magic involved, and feel free to look at the implementation if you're so enthused. But you can run these methods, and they run just like JUnit tests because they are JUnit tests. They're just doing some special things to be able to invoke your main method as an integration test. And allow it to do things like exit the VM and write to standard output, but you can still verify it here in your code. I'm going to walk through implementing some of those test cases that you guys came up with using these APIs. Any questions about them before we get started? Yeah.
Is there any special setup for integration tests?
Oftentimes there are. So if you're doing things like what we'll see once we get to the REST API project, there are integration tests that will first start up your web application, and then your integration test will hit that REST API and get stuff. For these, luckily there's not. The setup is just running the main method in a special way that it allows the main method to call system.exit without exiting the VM. Cool. Okay, so look over the list that you guys brainstormed, and what's a good first test case that we want to write? We're going to be exercising our main method using test-driven development. So let's come up with some test cases. Shout it out. Which one do you think we should implement first? No arguments. Well, we've kind of already done that. Well, are there other aspects of no arguments that we'd expect? So we got exit code of 1 and missing and it prints missing command line arguments. What else should it do?
Should you get a message?
Well, this is the message, right? Missing command line arguments is printed to standard error. Okay, the happy path. The happy path is is what? It's from the and that's the Dave student that's described there in the project. Okay, happy path, Dave student from assignment. That's an interesting place to start because it's pretty much all your end-to-end functionality. But you know, we can't really have it implemented. We have the unit test for it, so maybe this won't be so bad. Okay, let's go. So invoke main and student.class, and what are our arguments? Let's go see. Yes, these guys. Okay, so here's what I'm gonna do. I'm just gonna paste it raw and then put in. So this takes strings. So all this information comes in as strings. Okay, algorithms. So I heard a lot of you guys talking about the double quotes here. So this is an example from the Unix command line. And on the Unix command line, when you want to send in multiple words, something with a space in it, as one command line argument, you need to put around double quotes. This is Java code right here. That's invoking your main method. So here we don't need the quotes. Instead, see, because what we're doing here is we're invoking the main method from Java code, not from the command line exactly. So it's not going out and like invoking the shell and having the shell run your main method. So it's a little different. So here we don't need to have the double quotes. You get it? Because this is a Java string. The other thing was a command line argument from the Unix shell. Anyway, okay. So when we invoke main with this, we're going to throw it into a variable. We'll call it result. When we do that, what do we expect to happen? So given that, when we invoke, given those command line arguments, when we invoke the main method with those command line arguments, what happens?
Result get exit code equals to 0.
Okay. Get exit code equal to 0. Okay, so let's try that. Okay, so we expected 0 but was 1. Okay. So then, how do we want to? Oops, let's go to the main method. Okay, so we got that. So okay, so if args.length equals 0, do this. Otherwise, system.exit 0. Lame. Okay, yeah, it works. Let's make that test a little bit more interesting. So what else should happen when you give it these arguments? What else, guys?
The student should be instantiated with the parameters.
Okay. And what? And print out that sentence to standard output, right? Yeah, result in the following output. Oh wow, that's really lame. I don't really say that, do I? Huh. Okay, so result.get text written to standard out contains string equal to, maybe? We'll see. And then we're going to put that all in its big expected. This is going to be a string expected equals this big old thing, but it'll have two. Oh, see, it does have two spaces here. It just doesn't cut and paste from the. PDF very nicely. Okay, and then 2. Right, that's what we expect. So now if we run it, big failure because it was actually nothing. Okay, figure it out. Let's just figure it out. Okay, so back to student. Nope, student. Oh goodness, what do we want to do here? We got to parse our command line. How do we parse our command line? Well, okay, let's work backwards. We know we need to create a student. And we know we have a whole bunch of stuff. We have the name, we have the classes, we have the GPA, and we have the gender. Okay, so we know we need to get this far. No. Create. No, I want local variable. Oh, that's bad. Okay, so string name and a list of string. Oops, list of string classes. And we need a GPA, and GPA is of what? Double. Okay. It's having problems. I just can't create the variables because it's trying to reference the fields called gender, which is a reasonable thing for it to do. Okay. Oops, what doesn't it like? Oh yeah, it might not have been initialized. Okay. And then I want to print the toString of the student to system to standard out. So print. Let's do a print line, and then student.toString. So I'll be super lame? Yeah, let's be super lame. It'll make it pass. And actually, that'll be kind of good, because that will test these 2 lines of code right there. Sorry, so arrays.asList, and then what were those classes? Algorithms. Oh my gosh. Yeah. Copy and paste.
Is that Uncle Bob thing to do the minimal amount you need to make a test pass?
Yeah, I mean it's yes, and the reason that you do it is it keeps it simple. So and it helps you focus, because here again, because we're starting with a happy path, we're gonna have to implement basically everything, right? And so that's kind of where I'm getting to, where it's like that maybe that's not the best place to start, but we're gonna start there. We're gonna see what it's like. Okay, so now if we run it, oops, what didn't it like? Oh, it was so close. Oh yeah, it had that new line at the end because I did a print line there. Okay, we'll put a new line in our. Put a new line right there. Okay, it passed. It's lame, but okay, this is good. That actually, so that demonstrates to me that that code works, and there's value in that, right? That we can create the student, when it's all expected, but let's see if we can do better. Okay. So now, let's do this. Okay, we can be happy path. Let's see here. This is going to be arg0, right? First command line argument is always the name of the student. Let's try it and run it. Cool. What's the second argument is the gender. Okay. Is the gender, so that's args1. Args1. Okay. The GPA, that must be args3, right? Yeah, or args2. Args2 doesn't compile because that's a string, got turned into double. Anybody know how to turn a string into a double in Java? Parse double, yes. Yeah, not casting. Can't cast a. Yeah, well, a string is not a double. Right, casting is just in the inheritance. But that's good. Okay, do it that way. Sorry, what?
Do we need to try catch that?
Oh, do we need a try catch? Well, my test pass, I didn't need a try catch. Do I need a try catch? I don't need a try catch until I have a test that forces me to have a try catch. Oh, right. Okay. So, mental note: write one with it. Make exercise that piece of functionality. This is probably why you don't start with a happy path, by the way, because you convince yourself like I'm awesome, happy path works, and then like you get what the grader did is like, oh, grader really doesn't like the really focuses on the unhappy path. That's all we can test with this one. Okay, cool. And so now we got classes. How do we do classes? What do we need to do? Sorry? Append. Okay, append to the classes. Okay, so we're going to start out with an empty array, or empty array list. That's cool. And we're going to do to that.
Look over the remainder of the arguments and open.
Right. So int I equals 3 while I is less than args.length. I plus plus classes dot add args I. Manual array to collection copy. Oh, well, let's get it working first. Okay, that seems to work. Let's see what IntelliJ is telling me to do here. Place collections at all. Ugh. Nope. Sorry, IntelliJ. I'll take this. Okay. Well, that's neat. We're done, right? With this test. Okay, so we got the happy path. Happy path is good. Let's check it in. Version control. Implemented happy path for student main class, main method. Okay. Oh, you know, and by the way, since we're here, let's go back to the command line. And look for, where is it? Here we go, got my student. Let's do a Maven clean verify. So verify will run all the tests, including the integration tests. And it will also, this will give you the executable jar. So student, oh, it's wrapping poorly. Okay, jar, missing command line arguments. And so then let's go to the assignment and copy this, paste it here. Yay! Okay, so now it's working with the command line too. So you know this is cool, where it's like we have all these automated tests, and now just the command line just works. Okay, and now I mean I could sit here and execute this command line a whole bunch of times to do manual testing on this. Or I could invest a little bit more time and have automated tests and just have all the confidence that everything runs. Okay, so we're all set here. What's the next integration test that we should write?
Bad GPA.
Bad GPA. Okay, so let's see here. When GPA is not a double, what should happen? Ooh, exit gracefully, but you said exit 1? Okay. Exit with error message and code 1. Okay. So, copy and paste. We'll start with that. Okay, and so we'll extract that, and that'll be GPA. Will be bad GPA. Bad GPA? Yeah, bad GPA is like a 2.1. Invalid GPA. Well, these things matter, right? Yeah, that's kind of terminology. Okay. Bad. Okay. Okay, now when we invoke it this way, what do we expect? What is the result we want? I guess the exit code is 1, and assert that result dot get text written to standard error contains string invalid GPA. Yeah, okay, start there. Number format exception. So let's see here. Here's my code, student.111. Oh, look at that. Okay. So yes, we need to catch that. I'm going to put that into its own method, because I think it'll be easier that. Well, do I want to do that? Yeah, sure, I want to do that. Okay, and so I'm going to get a double now. Parse GPA. And then we're going to call this GPA. GPA string, nah, just GPA. Okay, create that. So now let's take a look at it. Okay, so now we want to wrap this in a try catch. and that is a number format exception. And what? What do we want to do? We want to say system.error.println, and we want to say invalid GPA, GPA, system.exit1. Oh, and then it's not compiling because it's saying missing return statement, which is true. So the Java language doesn't know about system.exit, doesn't realize it'll doesn't realize that there's no more code that will execute here. So just to make to make it so that it will compile, say something like, I don't know, double dot nan is nan. Sure. How often do you get to use nan? Right? Yeah. Put it on. I'll endorse you for nan usage in LinkedIn. How's that? Don't laugh. I'm sure someone's done it. Okay. Cool. What's this little yellow thing right here? Oh yeah, that thing. Okay. Neato. Okay. So that's a good deal. All tests pass. Run all of the tests. All 4 tests pass. Okay. That's good. So I think we got that one. What's next? You guys got all the test cases there in the community. What should we do next?
Like not enough arguments.
Oh, okay. Yeah, not enough arguments. Okay. Public void, not enough arguments. What happens?
Covered in the other test?
Oh, that's a good point. What we've tested 0 arguments. Think we should go for it? Think we'll find something? Okay. Yeah. Instead of not enough arguments, let's be more specific. How many arguments? Or maybe we should say what's missing. So like, missing GPA? Missing gender? How many do you want? How many should we do?
Gender.
Okay. Missing gender. Should be exits. So here again, exits with error message in code 1. Okay. So let's see here. If we then invoke main with just this, what should we expect? So let's see here. Assert that result dot get exit code equal to 1. And then what's the error message that we should put out? Missing gender. So you see, one of the things that I'm doing with the test cases is that before I write the implementation, I'm asking myself, what should my code do in these situations? So the project assignments don't tell you how to handle every situation on purpose. Right? If I did that, I'm basically giving you all the test cases. And you can come up with test cases sort of after the fact or as you code. Like he pointed out, it's like, oh, we're going to need to catch an exception here. True. Before you write that code that handles it, though, write the test first. Because that forces you then to say, well, it's not just about catching the exception. It's like, what should I do once I've caught the exception? So this is a good way to then specify, not only specify like in your head or in writing, but in code, here's what should happen. And then again, and so then you sort of have the specification through your tests. You don't need to write a big lengthy specification. So we run it. It fails. Array index out of bounds. Well, that's neat. Wasn't expecting that. Because, sure enough. Okay. What should I do here?
Maybe you should take JetBrains' advice and use the automatic collections. You don't.
Oh, but that would mean like this down here?
Yeah.
We didn't even get there. we got tripped up at line 110.
Okay.
Because we tried to look for args1, and there was only 1. So like arg0 was cool, args1 got an array index out of bounds exception.
Other than an if statement above.
Yeah. Yeah. So if args dot length is less than 1, no, that's greater than. That would be an important difference. Okay, then okay, so system dot exit 1. Oh, it has to be second, and then system dot error dot print line missing gender. Oops, didn't like. Oh, less than 2. Sorry. Here again, I caught myself right away, right? Rapid feedback. It's like, oh yeah, it's late at night, you just made some dumb mistake. Okay. Oh, but was missing gender. Sorry, lowercase g. Nice. Okay. It was red, it's green. Now I want to refactor something. I want to put this into a method, which will be print error message and exit. No exact method duplicates were found, though changed method is shown as 2 duplicates. Oh wait, I already have one. It's called print error message. Wait, exit string x. Method called. What is this thing telling me? Let's try that. And it's like I found something else like does that, and I found another thing that does that. Well, that was a pretty good refactoring. Okay. Nice. So that introduced this method right here. It takes that. I don't want it to be called X, though. I want it to be called message. Okay, that's neat. Let's run our tests again. All tests pass. Okay, are we done yet? It's late. I want to submit my code. It's late. I want to go home. Are we done yet? Do you have test cases that we should implement? Would you submit this code for grading? No, what's missing? What's next? Where are some more tests that we need to write? Remember, you can submit your code when all your tests are written and they pass. That's how you know. What's next?
What if there's no name and the first argument is the gender?
Okay. What should happen? So when first argument is gender, what should you do? In this case, the first argument is always the name. So then it's like your name would be female, which is valid. But if you don't have any other arguments, then it'll be that. But maybe you're hitting at something else. What happens when there is an invalid gender?
Exception.
What ought to happen? When gender... Oh, did we do that? No, we did missing gender. When gender is invalid, what should happen?
Exits with error.
Exit with error message? Okay. And we should probably just call it invalid gender. Okay. So, oops, and this is... Where's the happy path? Here's the happy path. Okay, so now instead of this, so we want everything else to be that. Okay, so then assert that get exit code is 1. Oops. Equal to 1. Okay. Anything written to standard out? Standard error? Invalid gender. Okay. Run it. We blew up. Okay, so here when we call toString, we get an unknown gender exception, invalid. Okay. How do you want to fix this? Well, this is where the exception's thrown. Yeah, we can do that. Catch invalid. Nope. Call it unknown. Unknown gender exception. And then print error message and exit. Unknown gender. Ex.get unknown gender. Oops, didn't like. Oh, invalid? Okay, we're going to call it unknown instead of invalid. Unknown, you're right, it's not invalid, it's unknown. And actually, let's just make sure that unknown gender equals unknown, invalid gender, unknown gender. Run it again. Oops, still doesn't like it.
You need to change
Oh,
invalid.
thank you. Okay. Red green. So I don't like this. So I like to be able to look before I leap. I like to be able to. I don't want to have to like go to all the work creating a student only then to find out that the gender is invalid. And so I think what I'm going to do is, well, and so like what I could do, and it's getting late. What I think I would do is I would refactor it to like maybe add like a helper method that would just take a string and like tell me, is it a valid gender? Something like that. And then I would call that before I try to invoke the student constructor or something. But I'm not going to take the time to do that. Probably really what I would do is I would, in the student constructor, I would replace, instead of having gender be a string, I would have it be an enum type, because this program only supports two genders, so it probably makes more sense for it to be a enum. But this is good enough so this test is good enough for right now. I can save that for refactoring for the morning when I'm more fresh, for instance. Okay, so let's run all my student tests. Okay, everybody's passing. Okay, now what else? My gosh, can I submit this and go home? I mean, come on.
In the passing test, you need to check to see that there's no error messages.
Oh, that would be a good idea. Yeah, so like nothing is written to standard error. Yeah, that's cool. That's a good idea. So let's augment the happy path. And so then assert that result.get text written to standard error equal to, is it null or is it empty? That's interesting. I don't know which one it'll be. Sort of depends on the how I captured the output. It is empty. Okay, that's good to know. So yeah, that was a good catch there. I suppose equally you could say, hey, nothing written to standard out. Okay. How's this looking? What other error checking would you do? Missing GPA would be one other one, so I don't want to go through that now. But you guys have seen the pattern. Any other tests that you like really feel strongly that we should implement?
Do we have a case for 0 classes? Like if somebody's taking 0 classes?
Oh, that's a good point. Yes, making sure that works. That probably that would be interesting. Now why is that interesting? We have a unit test for it, so why bother to test it from the main?
Make sure that it's parsing correctly?
Yeah, okay. Yeah. So probably, not a bad idea to, so you're going to copy the happy path. Actually, let's just copy the whole happy path. Public void, it's okay to take 0 classes. Whatever. Okay, and here, yeah. Nope, it's not okay to have no GPA. And it's taking 0 classes, period. New line. He says, okay. Oh, yeah, I probably just got the thing wrong. See the difference. Sorry, what?
For now, no.
Oh, no classes instead of 0 classes. Uh-huh. No class. There we go. Okay. Worked as expected. That's good. Gives us a little extra confidence. Okay. Okay. So let's wrap up. So let's commit, and while I'm doing that, what did you think about tonight? What do you think about test-driven development? What are some of your observations? What are some of the things that you thought were interesting, good, things that were not so good, and things that you're still not too sure about?
So we're writing all these tests, right? We're doing that specifically in the test class,
Mm-hmm.
like a student test class. I guess I'm a bit confused is like how that gets implemented into the student class itself. Are we writing that into the student class? Did I miss that?
So yeah, the student class is different from your classes in that the main is in the student class. In your classes, project 1 is a separate main. So for simplicity, student has a main method. I could have a student main in addition to the student class. Yeah. That's an important difference. It makes a difference. Do you really think it was going to take 3.5 hours to implement this class? It's a very legitimate criticism of test-driven development. For something simple like this, here again, this is just for demonstration purposes. I encourage you to try it on your own when you're working on something like Project 1, and certainly your later projects, where there's more stuff involved and more functionality there that you could break by making some change. So I think that's when you'll get a bigger payoff. And another thing that you might want to consider is, so the attempt that what I did was I implemented my unit test first and then did my integration test, which is probably the right thing to do. But something you might want to experiment with is use your integration tests to then drive your implementation and your unit tests. So what I've done in the past is I've started with the integration test. I started with Happy Path. Said, okay, that's ultimately where we need to get to. Let's start filling in things in the meantime. I don't know. It all depends. That's sort of like a front-to-back way of doing it, as opposed to like what we did was more back-to-front, where it's like, let's get student all set on its own. So, the student constructor and the toString method all set on its own, and then learn about this integration stuff, which then drives the main method. But it's really not that much code, right? I mean, it's 145 lines, and then, of course, how big is our... So we had 70 lines of integration tests, and then we had 161 lines of unit tests. And that's a good sign, right? When you've got more code to test your code than the code actually is. To me, that says that, okay, this code is well covered. This is going to work. And so then when the grader throws some test cases at this, you did some good brainstorming. You thought about a lot of the edge conditions. We implemented virtually all of them. And so then, I think, a couple more tests of the command line parsing, and I'd feel pretty confident submitting this. Yeah.
Will you show us how to use the IntelliJ code coverage?
Oh, if I knew how to use IntelliJ code. Yeah. Let's see if I can do that real quick. There is a way. Let's see here. Run student test with coverage. 55% of lines, and then I think, let's see here, student. So over here, I guess, over here in green, this is all of the lines. Oh, that's interesting. Like, there's no code there, so it says, oh, that line's not covered. That's weak. So yeah, I mean, here we did a pretty good job. And see, when you do test-driven development, if you have the discipline to only write code to make a failing test pass, you pretty much have 100% code coverage. So yeah, I mean here, okay, it's like
Missing 3 methods. Is that it?
no, it's a method percent. Yeah, 5 out of 8. So which? Oh, yeah, okay. Main doesn't have any unit. I just ran the unit test. So okay, I wonder. I probably can't do that. So okay, not surprisingly, main and its methods aren't exercised. We got 100% coverage on our exception. They had like 2 lines of code. So yeah. So I'm probably feeling pretty good about this. Cool. Okay. That's all I got for tonight. Any last questions or thoughts? Okay. Well, thank you very much for your time tonight. Next week we will we'll learn about pair programming, and we'll start having you guys do some code here in class so you can get more practice doing test-driven development and working with other people. Until then, have a great weekend.